This week on the show, we have FreeBSD 11.2 available freshly out of the oven, setting up an MTA behind Tor tutorial for you, running pfsense on DigitalOcean, 1 year of C, and using OpenBGPD to announce VM networks as well as the power to serve. And on top of that, there's a BSDCan trip report for you in this week's episode of BSD Now. BSD Now episode 252 goes to 11.2, recorded on the 27th of June 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have great headlines for you this week because they're so fresh out of the oven, we almost burned our fingers because just basically minutes ago, FreeBSD 11.2 got officially released. And of course, we're covering that.
Yes. So just like an hour before the show went live, I was scrambling to get the notes and write them up because they hadn't actually been released yet. So FreeBSD 11.2 is released today, which is June 27th, if you're watching this later on. And we're going to talk a little bit about some of the highlights, including the versions of OpenSSH have been upgraded to 7.5 patch 1, and OpenSSL has been updated to 1.0.2 patch 0. Clang, LLVM, LLDB, and compiler RT have all been updated to the version 6 from the LLVM project. libarchive, which is what backs tar and a bunch of other tools, has been updated to 3.3.2. The VXO has been updated, and lots of major driver changes.
Yep.
Actually, the most important one is not here.
Yeah, it's been added to the release notes retroactively, I guess. They forgot about it. Oops.
Yeah. So the biggest news is the DRM Next Kmod driver that supports all the Intel integrated graphics cards has been made available for FreeBSD 11.2. So with that, you'll be able to have accelerated graphics and working suspend resume and all that fun stuff on your FreeBSD 11.2 machine.
Yeah, and that's for especially the laptop users and the people who want to run the latest desktop environments with the latest shiny graphics support.
Yep, and then for higher performance stuff, there's also a bunch of other drivers that have gotten updates. The CXGBE driver for Chelseo 10, 25, 40, 50, and 100 gigabit NICs has been upgraded to version 1.16, supporting the T4, T5, and T6 series of network cards. The Intel IXL driver for 10 and 40 gigabit NICs has been updated to version 1.9.9K. And the NetGraph PPPoE driver has been updated and adds support for user-supplied host unique tags. And, big deal if you're running an ISP that uses PPPoE.
Yeah.
There are also some new drivers, including the Mellanox MLX5 IO driver, which provides a new IOCTL interface, which is paired with a new tool that will allow you to program those cards from userland. So the new IOCTL interface supports the Mellanox ConnectX-4 and ConnectX-5 cards, which cover the 10, 20, 25, 40, 50, 56, and 100 gigabit NICs. So all the modern NICs there. The Emulex Fiber Channel 8, 16, and 32 gigabit host adapters driver have been updated. And we've added the Smart PQI host bus adapter. So this supports the RAID controller in the HP Gen 10. So the Smart Array controller on newer HP servers is now supported as well.
Excellent. I see people updating right now already.
Yep. Taking a quick trip through userland, we see new syslog now has the ability to add RFC 5424 compliant messages to log files when it rotates them. The disk info utility has two new flags, -S to display the serial number and -P to display the physical path for disk on the storage controller. previously you had to use cam control, and it was this command if you wanted it for SATA, and this command if you wanted it for SCSI or SAS. Whereas the disk info utility with the -P and -S flags allows you to get just the serial number of the drive and get it in a script-friendly way. So it's easier to script doing things like labeling your disks based on the serial number. The top utility has got the ability to filter to multiple usernames now. So if you do top-U BCR and -U Alan Jude, it'll show those two users instead of only the last one. Quite useful. The UMount utility has a new flag -N, which is an even stronger than a force unmount for NFS mounted file systems. Sometimes if there are outstanding things blocking it, even a umount-F wouldn't actually unmount an NFS mount. But now with this N flag, you can force it to go away. The PS utility has gained the ability to tell if a program is in a capsicum sandbox. So in the flags field, if you see a C, that means that program is running inside a sandbox.
Oh yeah, so you can check how secure that process is.
The service command, service foo start and so on, has a -J flag now, where you can give it the name or numeric ID of a jail and have it actually start or stop that service in that jail, which is quite useful. Getting back to the Mellanox tool we talked about, MLX5 tool utility has been added and is used to manage ConnectX-4 and ConnectX-5 devices via that MLX5 I/O driver we talked about earlier. This allows you to update the firmware and all the other things you might need to do on the card with its own utility. So that's a native utility to update the firmware and so on, which is quite useful. Ifconfig, you can use the ifconfig some adapter ether option to change the MAC address of an adapter. It now supports the special keyword random to select a random MAC address. Quite useful if you're using, say, the e-pairs or TAF devices or something for doing virtual machines or something, and you need to make sure you get a random MAC address each time. You can actually specify that now.
Nice.
The dwatch utility was added. If you want to know more about that, check out the slides and so on from BSDCan. EFI boot manager has been added, which allows you to actually set variables in the non-volatile memory in the EFI BIOS, which will control the boot code. And you'll be able to do things like, hey, next time boot this version or this data set instead of that one, and so on. ET dump has been added. This allows you to dump the El Torito boot catalog information from a CD. This is part of the ongoing work to be able to make a hybrid image that's both a CD/DVD image and a memstick at the same time, but being able to look at an ISO and make sure that it's going to be bootable before you ship it.
Actually reboot the machine, and oops, this thing won't boot. But that's
the Linux
important.
compatibility layer has added support for the Musl consumers, so you can actually run the MUSL libc instead of GNU libc as well. So that's all been worked. Any rough edges there have been smoothed over. Then the fdeskfs, so the file descriptor file system, has been updated to support the Linux-specific interfaces devfd and /proc/self/sd behavior, so that those are available, making Linux compatibility that much better. And Beehive gained support for Virtio console, so that you can have a higher performance console instead of doing, old-fashioned serial.
Also nice to have, yeah.
And one to watch out for, the default. So when you're typing a Geli password in at boot, it no longer echoes a number of stars equal to the number of characters you've typed, so that people can't tell how long your password is. If you would like the previous behavior, you can use the Geli configure command to set the flag and enable the echoing behavior.
Okay.
Yep. And just to mention, in addition to the regular CD and DVD ISOs and memsticks and the pre-built VM images, You can download FreeBSD 11.2 as a pre-built VM image in RAW to use in, say, Beehive or to convert to anything else. QCOW for, say, KVM and QEMU. VHD for virtual PC and Hyper-V. And VMDK used for, VMware and everything else. In addition to all those, you can also get FreeBSD 11.2 on all your favorite clouds already. Even though it's only been out for an hour, you can get it on Amazon EC2, Google Compute Engine, Vagrant, and Microsoft Azure.
Yep, there should be something in there for everyone, for some people in the cloud.
And I expect it'll be on all your other favorite cloud providers like DigitalOcean and so on. I would expect in the next
Soon
day or
enough.
two. It won't take very long. And in addition to all that, there's a generic ARM64 image, so you can use on, say, a Pine 64 or Raspberry Pi 3 and anything newer like that, 64-bit ARM. But for 32-bit ARM, there are special images created for the Gumstick, Banana Pi, BeagleBone, QB Board 2, Hummingboard, Raspberry Pi 2, Panda Board, and Wand Board. So if you have any of those devices, you can also get pre-built images for 11.2. There's lots more goodies buried in the show notes. Do check out, or not, in the release notes. So I included the URL to that in the show notes.
Mm-hmm. Yeah, so run FreeBSD update, or if you are that desperate, run it from source compile, which both ways brings you to the new.
Do a fresh install, whatever you prefer.
Yeah, that brings you to the new goodness. All right. Thanks for the release engineering team on FreeBSD for making that a timely release, and everyone who contributed code to make that happen. Thank you as well. Next item that we have this week is setting up an MTA behind Tor, which is, of course, the Onion router to kind of divert where your traffic is going so that no one can watch you. And we have here basically a pretty nicely outlined how-to article on GitHub by our friend Sean Webb. And it goes like this. This article will document how to set up OpenSMTPD behind a fully Torified network. Given that Tor's DNS resolver code does not support the MX record lookups, care must be taken for setting up an MTA behind a fully Torified network. And OpenSMTPD was chosen because it was easy to modify to force it to fall back to A/AAAA lookups when MX lookups failed with a DNS result code of no TIMP.
As in not implemented.
Yep, so this is not here. Note that as of the May 8th, the OpenSMTP project is planning a configuration file language change. So there will be a way to migrate, hopefully. The proposed change has not landed. Once it does, this article will be updated to reflect both the old language and new. And the reason to use an MTA behind a fully Torified network is to be able to support email behind the .onion top-level domain. And with this setup, will only allow us to send and receive email to and from the .onion top-level domain. So that's the restriction there, but also gives you the possibility to make it non-traceable, hopefully. So requirements we have is, of course, a fully Torified network. So that's a must if you want to do this. A hardened BSD as the operating system, a server or virtual machine running hardened BSD behind a fully Torified network, user ports empty. Okay, we'll see how that evolves. And an already pre-populated hardened BSD ports tree. Okay, that's where it's coming from. The question is now, why use hardened BSD? We get all the features of FreeBSD, ZFS, dtrace, Beehive, and jails, among others. With enhanced security through exploit mitigations and system hardening, Tor has a very unique threat landscape, and using a hardened ecosystem is crucial to mitigating risks and threats. And also note that this article reflects how he set up the MTA. He included the configuration files verbatim. You will only need to replace the text that refers to the .onion domain of yours. So don't just copy verbatim. Think about what you're typing in there and make suitable replacements. Okay, so steps are basically outlined here. You start with the installation. That's pretty straightforward using the package system, and you install your required software, in this case Dovecot, and some small utilities there. Then you start making changes to your mailer.conf, making the replacements from the, of course, send mail to your OpenSMTPD. And
I
then
think that happens for you when you install OpenSMPD from packages or ports. It's like, would you like to activate it in your mailer.conf?
Yeah, there's a dialog that does it for you. But in case you want to check that these replacements will make, you can figure that out in your mailer.conf. Then you generate the cryptographic key material. Of course, you use OpenSSL for that, making sure that...
if you were not doing this specifically for Tor, where you can't actually prove the ownership of the domain, you would probably use Let's Encrypt nowadays. But since this is off of the regular internet, you would generate a self-signed key still.
Yeah, so yeah, that's a good point. Having that not in the usual way. Then you start the Tor configuration, where you basically create your Tor RC file and add a couple of networks there. And of course, replace the IPs in there with your MTA system that you have. Don't just copy the one that we have in the article here. And then you can check your host name that everything has been set properly. And then you go start the OpenSMTPD configuration. Again, this is the one that might change in the future when there's a configuration language change. But if you know a bit of PF configuration, then you see that this is pretty similar. If you haven't used OpenSMTPD before, they have a similar language that's very that speaks to you what it does and what it accepts and things like that. So onto the Dovecot configuration. That's pretty much also straightforward. If you've done Dovecot before, you basically define which is your outgoing SMTP or MTA mail server, and that's a long listing here, but that's Dovecot config standard. That's not too hard. Optionally, there is a section for webmail access if you want to run that. So there's basically installing Apache, and then a rain loop, and of course the mod Apache 2.4 module, so that you can pull it out nicely into Apache, and then you can run webmail in your Torified network. Very nice. This is pretty straightforward and not too long of a how-to, so this should be not too difficult to replicate.
This week's episode of BSD Now is brought to you by IX Systems. Head over to ixsystems.com and check it out. They have their new guide up now, where you can get the... where it's actually not loading the right page for me.
Is it?
Fault, not yours.
Yeah, so IX Systems are the folks that give you your servers for your open source workloads. If you have a specific need in the area of, let's say, big data, cloud, or let's say you need a backup system, for example, then you should give them a call and tell them what your needs are, and they will build you exactly a system towards that need, not just take one from the shelf and send it to you, but they will actually give you a couple of questions that you should answer, and that way they can provide you the best system for your use case. Or you can also buy some of their FreeNAS minis if you're just starting out, doing your backups, for example, in the office or at home. And that's also scalable up to 8 storage drives for maximum capacity. And you can also get the full true rack. So they have pretty much everything from the smallest server, which is quite powerful already, back to rack mounts, high density filers, to the full rack of IX storage systems. And that's pretty powerful.
Yeah. So here's what I was looking for. Their new guide, if you go over to ixsystems.com/BSDnow and check it out, you will see the open source storage is disrupting the enterprise market, which is much more interesting than the
server buying guide.
Yeah, well, it's new and talks a bit about why you probably want your new storage system to be based on open source rather than something that isn't.
Oh yeah, so people who have been with us on the show and haven't seen this PDF before, they should make an effort to go to that URL and download the new PDF and check that out. So, but they have also a couple of interesting things going on, not just on the server side, but also on the kind of a marketing thing. But they also were featured on Forbes.com recently. Would you like to read that? Do you have that present?
Just a little bit about it, but basically they have strings attached, knowing when and when not to accept VC funding. And they talk about how over the years, IX has listened to a number of VC pitches, but turned them all down, and why they did that each time, and why that's worked out better for them and for you.
Yeah, as a customer.
It has a lot to do with the fact that, unlike a lot of other startups, the people at IX Systems are not looking to sell their business and stop doing this. They like what they're doing and they want to keep doing it. And so the only way to do that is to do a good job and get customers to come back.
Yeah, and once you talk to the IX folks at a trade show or in a conference, you'll immediately get the sense, yeah, this is an IX family. They're like a big group of people that like to work with each other and have really this familiar family thing going on in the family, in the company. That's making it also a nice workplace. And it reflects in the products and the software that they deliver.
So they also have their trip report. They recently got back from Southeast Linux Fest, which happens to take place overlapping with BSDCan. And so they had a great time visiting their friends on the East Coast, and they talk about the unveiling of the Project Trident, the new version of the TrueOS desktop, basically, and talked about that. There was also a giveaway of a FreeNAS Mini and a prize there, and then also they gave away a Lenovo ThinkPad. And actually, we have BSD Now producer JT here, pictured with the winners of their laptop.
Oh, excellent.
And they talk a bit more about how IX was there and what they talked about and what they saw at the Southeast Linux Fest.
Oh, cool. I haven't seen that yet. Oh, yeah. There we go. Yeah, this is just IX System as we know them. It's just a pleasure to work with them. And again, if you have a server need, give them a call and you will see that they will provide you with the proper system for your use case.
Yep. And if you remember a couple of weeks ago, we talked about running a FreeNAS in the cloud at, say, DigitalOcean. This week, we actually have a blog post talking about doing the same thing, but with pfSense or OpenSense. So they say they're using pfSense for just about everything from their home lab to large-scale deployments, and it gives all the fanciness that you would get from any brand name firewall appliance, and it's free. They also say that they've been using DigitalOcean and like that a lot, and suggest that if you haven't tried it yet, you head over to jupiterbroadcasting.com, check out the cool tech podcasts, and /maybe get a coupon code, which we'll get to in a little bit.
Stay with us, yeah.
Yes, if you need one of those, that'd be at do.co/BSDNow or the coupon code FreeBSDNow. Anyway, so while you can, when you create a droplet, you can select between FreeBSD, 11.1 and 11.1 ZFS, and hopefully very soon 11.2. When it comes down to appliances, they don't have pre-built options for FreeNAS and pfSense, so you have to do it yourself a little bit. But this tutorial will walk you through it. So we choose a FreeBSD 11 droplet. They chose the 1 gigabyte of memory one, which only costs $5 per month or 0.7 cents per hour. Then they choose a location. You can choose between New York, San Francisco, Amsterdam, Singapore, London, Frankfurt, Toronto, and Bangalore. And you want to add the extra network interface. So you tick the private networking box, and that way you'll get 2 network interfaces instead of 1. Then you tell it which SSH key to let you log in with and how many of them you want, and away you go. Once the droplet is ready, you want to SSH into it and download the latest pfSense. once you've downloaded pfSense, you can turn off swap on the running VM, which will provide you a handy partition that's no longer being used. So after you swap off, we can write that downloaded image into that swap space. So we just unzip the downloaded image and pipe that into DD and write it into that swap partition. Okay. Then when you reboot, you'll get the pfSense bootloader, and you'll be able to install into your system. You'll want to switch to DigitalOcean's HTML5 control panel, which allows you to have direct keyboard access even when the operating system isn't running, which is super handy. And use that to reinstall pfSense, basically.
Okay. Yeah, the swap partition trick.
Yeah. And so then you reformat the disk, splat pfSense down on your disk there, and then once it installs and you boot up, you now have pfSense installed in your droplet. So you can head over to the interface, log in, and start configuring pfSense just like as if it was on a box at your house. But now you can use it to provide firewalling and NAT for all your other DigitalOcean droplets.
Yeah.
You just check that private networking option, and each of your VMs will now have a private network that goes through the firewall. And since the way the bandwidth quotas work on DigitalOcean is all your droplets in the same data center or have their bandwidth pooled together, it means even though you're going to route, say, all your traffic through your firewall, it's not going to impact your bandwidth quotas because you get the bandwidth of all the droplets that are running available to the firewall that's going to do all the work. And the traffic over the private network is free.
Yeah, see what benefits that gives you?
Yeah. And then, there's a little note here. Special thanks to Tubsta, who's a BSD aficionado that's posted a number of things that we've talked about. And then thanks to Alan, Chris, and Benedict for the BSD Now podcast.
Yeah, thanks for watching.
You for writing this tutorial and making it easy for everyone else and giving us something to talk about. But if you're more interested in actually getting this going, you can follow the tutorial step by step and you'll be good to go.
Yeah, that's the circle of BSD Now. People post stuff, we report it on the show, people thank it on the show, and then, yeah, we'll go full circle here.
Yes, we talk about Tubbs' post that leads to somebody else saying, instead of OpenBSD on the droplet, I want pfSense, and doing that. And then thanks for the podcast for telling me about Tubbs' post. And then, the next person will base their work on your pfSense post, and it's on and on and on.
Idea proliferation through podcasting. Yeah. Excellent.
It's how open source works.
Yeah. So, time for the news roundup this week. We have as our first story in this segment, 1 year of C. So this looks interesting. So the brain dump here says, 1 year of C. It's now nearly a year that I started writing non-trivial amounts of C code again. The first socol_gfx.h commit was on the 14th of July, 2017. So I guess it's time for a little retrospective. In the beginning, it was more of an experiment. I wanted to see how much I would miss some of the more useful C++ features, for instance, namespaces, function overloading, simple template code for containers, and whether it is possible to write non-trivial code bases in C without going mad. Here are all the GitHub projects I wrote in C. So there is Socol, a slowly growing set of platform abstraction headers. There is Socol samples, examples for Socol. Chips, it's an 8-bit chip emulator. Chips test, which tests and executes, has examples for the chip XM emulators, including some complete home computer emulators. So minus the sound, but it's still a nice emulator here. All of these that are around 32 Sorry, let me start over. All of these are around 32K lines of code, not including third-party code like FlexGL and handmade math. I think I wrote more C code in the recent 10 months than any other language. Oh, wow. So one thing seems to be clear. Yes, it's possible to write a non-trivial amount of C code that does something useful without going mad. And it's even quite enjoyable, I might add. So here are the things he's learned. First, pick the right language for a problem. C is a perfect match for WebAssembly. C99 is a huge improvement over C89. The dangers of pointers and explicit memory management are overrated. Okay. And less boilerplate code as well as less language feature anxiety. And the conclusion here is, all in all, my C experiment is a success. For a lot of problems, picking C over C++ may be the better choice since C is a much simpler language. By the way, did you notice how there are hardly any books, conferences, or discussions about C despite being a fairly popular language? Apart from the never-ending bickering about undefined behavior from the compiler people, of course. Yeah, so there simply isn't much to discuss about a language that can be learned in an afternoon. I don't like some of the old POSIX or Linux APIs as much as the next guy, like the IOCTL, the socket API.
IOCTL can be pretty nasty. The socket API, I don't think there's video of it, but Paul Hennenkamp gave a great talk about how terrible the sockets API is back at BSDCan in Malta. Although, Tom Jones, a recently joined committer to the FreeBSD project, gave a talk about it at FOSDEM 2017 about an alternative to the sockets API that actually looked pretty good.
Okay. Yeah, but that's the Linux socket API, not the BSD socket API.
Well, Linux uses the BSD sockets API. It's the same API.
Oh, okay, I see.
Have you ever tried to create a socket in C? It's pretty terrible.
Okay, yeah, not something you would start out with. Okay, yeah, so that's the APIs, but that's an API design problem, not a language problem. It's possible to build friendly C APIs with a bit of care and thinking, especially when C99's designed initialization can be used. C++ should really make sure that the full C99 language can be used from inside C++ instead of continuing to wander off into an entirely different direction. Okay, that seems like a well-supported start into a C programming career, I guess, or a return to that career.
Yep. So next up, we have configuring OpenBGPD to announce VM virtual networks. So it starts, we use BGP quite heavily at work, even though it's not interacting directly with BGP that much. It feels like something very useful to learn, at least at some level. The most effective and fun way of learning technologies is finding some practical application. So I decided to see if I could help to improve the network management of a large number of virtual machines. So the setup is fairly simple. We have a host that runs Beehive VMs, and I have a desktop system from where I wish to SSH into those VMs, and all of these machines run FreeBSD. All VMs are connected to each other through a bridge and have a common network in the 10.0.1.0/24. The point of this exercise is that is being able to SSH to these VMs from the desktop without adding additional static routes and without adding VM host external interfaces into the VM's bridge. So to do this, they installed OpenBGPD on both the host of the VMs and I guess the desktop. So on the VM host, they created a bgpd.conf that sets their AS number, has the router, creates the network, and defines a neighbor of the desktop and has its AS number. So in this case, router ID is set to the VM host IP address on my home network. The fib update no is set to forbid routing table updates, which I initially set for testing, but keeping it as VM host is not supposed to learn new routes from my desktop machine. And the network announces that new network. Then over on the desktop, we define a different AS number and have our router ID, but we do want to update the routing table on the desktop about all the routes it learns to the VMs. And then we define the neighbor of the VM host and its AS number. So now, every time a new network shows up on the VM host, it'll be announced via BGP to the desktop, So each of those private networks that isn't actually bridged to the internet or to the public interface on the VM host will be reachable from the desktop. So it's pretty simple. The config on the desktop is pretty similar to that on the VM host, except for we are allowing updates to the routing table. So then in the rc.conf, we just enable OpenBGPD. And then once it's running, we can do BGPCTL show summary on each, and we see they each know their neighbors, and we know how long it's been up, and so on. And then when we do BGPCTL and look at our neighbor, the VM host, we see information about all of its routes.
Yep, there it is.
And so when we show RIB, we see that if you want to get to the 10.0.1.0 network, we go through the VM host via our desktop. And then now we see that route actually gets added to the routing table on the desktop machine, and we're able to ping all the various VMs pretty easily. So it says, as mentioned already, similar results could be achieved without using BGP by adding static routes or bridging the interfaces so that the traffic would all be in the same broadcast domain. And you could do that. But for the purposes of this exercise, it gets some basic hands-on experience with BGP. Right now, I'm looking into expanding a setup in order to try to more complex BGP scheme. For example, having a separate network for each of the host VMs, or each of the VMs on the VM host, instead of having one network. And then you'll learn a different route for each VM, and which also kind of let you know if the VM is up or not.
Yeah.
That's also considering some kind of software switch in front of the VMs and maybe a second VM host, so that, with BGP, you're actually learning about two different networks, and the VM host could learn about each other. So the VM on host 1 could talk to a VM on host 2.
Yeah, it's your little internet on your own virtual environment.
Yeah, it's also just a great way to learn about BGP on top of to do something useful on your desktop.
Yep. Very nice. And it's easy to follow with the examples, so
yep.
People should try it out.
So as we mentioned before, with the tutorial on how to run pfsense on DigitalOcean, if you head over to digitalocean.com, you can create a virtual machine out in the cloud where you can start with a gig of memory, or maybe you want 2 or 3 or more gigs of memory. And you get virtual CPUs and some SSD-backed storage, and starts with 1 terabyte of internet transfer for that $5. Makes it pretty easy to get a very fast VM out on the internet.
Yep, and it's easy to set up. Within seconds, your machine is ready, called a droplet, and then you can, run your favorite services on it, or the latest version of FreeBSD, for example. If that's not available yet, then you just do a FreeBSD update and get it from the FreeBSD update servers. And you can watch your machine with comprehensive monitoring, like how much bandwidth it's using, how much CPU and memory, or how much disk space it's going to consume. And if you see that it's going to get, a little bit small, then you just scale up a little bit, give it a little bit more RAM, give it more CPUs. And you can see that it's quite easy to do that on DigitalOcean.
Yep. And with the new flexible droplets, the $15 size, you can choose between 1, 2, and 3 gigs of memory and 1, 2, and 3 CPUs, but all of them come with 3 terabytes of bandwidth.
Yeah, that's a lot. I mean, you can do a lot of things already with this small package, and most people don't have this as a desktop sometimes, so they mostly run it to connect to the cloud and then do all the stuff from there. For example, if you're at a conference or staying in a hotel and you're not sure, is this Wi-Fi secured? Then you can tunnel via SSH to that DigitalOcean droplet of yours and use that as your encrypted tunnel to the outside world. There are pretty much a lot of possibilities once you start thinking about, I could use this as a jumping point into other things or run things on the internet, of course, properly securing them. And there are also firewalls on DigitalOcean for securing off certain areas of the evil internet, or making sure that only certain IPs can reach your little droplet, or multiple droplets if you have those. So that's already available as well in DigitalOcean's management utilities. They also have their own object store. So this is DigitalOcean Spaces, which is pretty similar to S3 from Amazon. But you can also get that for your little droplet to have an object store.
Right. So moving on, don't forget the coupon code FreeBSD Now, or go to do.co/BSD Now. So the FreeBSD Now coupon code gets you a $10 credit. Or if you don't have an account yet, if you go to do.co/BSD Now, you can get a $100 credit for 60 days.
Yep, and that's a lot to run off the metal.
If you're running the $5 a month droplet, you could start quite a few of those over 60 days. Again, because while it's $5 a month, it's actually $0.007 per hour. Meaning that if you start one today, where it's the 27th, your bill at the end of the month is only going to be a couple of cents because you've only run for 4 days.
Yep.
Anyway, next story is from nocomplexity.com, talking a bit about why they use FreeBSD. And this is a post they made for FreeBSD Day. So all people within the IT industry should know where the slogan, "The power to serve," is exposed every day to millions of people. But maybe too much wishful thinking for them. Without the power to serve, the IT industry would look totally different than it does today. Companies like Apple, Juniper, Cisco, and even WhatsApp would not exist in their current form. So they go on to say, "I provide IT infrastructure services to make your complex IT landscape manageable, and I love to solve complex security and privacy challenges. Complex challenges where people, processes, and systems are heavily interrelated. For this knowledge-intensive work, I often run some IT experiments, and when I run experiments, I like to choose, rent some cloud-based instance or do it myself on premise. Running your own development experiments on your own infrastructure can be time-consuming. However, smart automation saves time and money, and by creating your own continuous integration, continuous delivery platform, you stay on top of core infrastructure developments. Even hands-on, knowing how things work from a technical hands-on perspective gives a great advantage when it comes to solving complex IT and business problems. Making a clear distinguish between a business problem or an IT problem is important. Business and IT problems are related, sometimes casually related, but more often indirect by one or more nonlinear feedback loops. Almost every business depends on an IT system, and bad IT often makes your customers leave the business. So they talk about a few things. One of the things that FreeBSD is for this person is FreeBSD jails. In 2015, I had luck to attend a presentation by the legendary hacker Paul Henningkamp, who created jails back in the late 90s. Check his BSD bio to see what he has done for the FreeBSD community. FreeBSD jails are a lightweight way to virtualize your system without the enormous overhead of virtual machines. Now that the development on Linux of LXD and LXC are more mature, there is finally again an alternative to a nice chroot Linux-based system. And then you get, versus the overhead management complexity of things like Kubernetes and Docker. But FreeBSD means control and quality. There's an open source package I need. I want to install it from source. It gives me more control and always more understanding of what's actually happening. If a complete open source software package is not available in the FreeBSD ports collection, it's usually pretty easy to sort it out. And with 32,644 packages currently available, it's probably already there.
There's a good chance for that, yeah.
Yep, and FreeBSD is, of course, BSD licensed and works very well, and there's still a strong community with lots of strong commercial support around the world. Of course, sometimes a GPL license makes more sense. So besides FreeBSD, they also like GPL license for certain things. And it is their hope over the next 25 years that the battle between BSD and GPL and be more rationalized and normalized.
Yeah, one can only hope.
Yeah. And then there's a note about FreeBSD Day at the bottom and FreeBSD's 25th anniversary.
Yeah, that sparked a lot of people, sharing the love for FreeBSD and what it has done for them over the years as a tried server operating system or as a home use system. So there were a bunch of stories out there, and we'll try to collect more of them and see where do they put them in the future show. So yeah, that's a great report. So thanks for that. And the next one is nice. You'll like that one. So remember last week we were like, okay, we told our stories how cool BSDCan 2018 was for us, and we asked you for your trip reports. And Dave was the first one who, used his keyboard to send us his trip report, and we cover it today in this week's episode.
Yeah, so Dave starts off, hey guys, during the last show, you asked for a trip report regarding BSDCan 2018. Well, this was my first BSDCan. It was actually my second BSD conference because I had gone to FreeBSDCan 2017 in Reston, Virginia. And that was Dave's first conference. Anyway, he goes on, arriving early Thursday evening, and after checking into the hotel, I headed straight to the Red Lion for registration, picked up my badge and swag, and then tried to head towards DMS. The only thing is, I couldn't find this DMS building. Because on Google Maps, it's not called DMS, right? That's the university shorthand for it, not the actual name of the building and so on. Maybe we could have done a little bit better job there. There are a couple maps on the BSDCan website, but I had a similar problem actually trying to find Henderson, where the Hacker Lounge was.
Yeah.
Eventually, I found the right map on the university's website, where only if you zoom to a certain level does it actually print the HND or whatever on the building. So maybe we could make a custom Google map with just like... so one of the maps on the BSDCan website just has so many markers, it's hard to tell what's what.
Yeah.
So I would maybe suggest making one with like...
the essentials?
8 markers on it. Like... Henderson, U90, and Desmarais. So the 3 buildings that the university care about. The
Red Lion.
The Red Lion, and Les Suites and Cora or something like that.
Some of the hotels where other people are staying.
Yeah, just a basic idea of this is probably where you're staying, and this is probably where you want to go, and that's it. And maybe also just actually having the street addresses of a couple of those places so that people can find them with their regular map app on their phone or whatever.
Yeah. But anyway, he managed...
Now that I'm done digressing, Dave goes on. Fortunately, I found another BSDCan veteran who was heading there themselves, and I just followed them. My only suggestion is to include the full building name and address on the website, because Google calls it Desmarais, not DMS, and so on. Anyway, once I made it to the newbie talk hosted by Michael Lucas, and it highlighted places to meet and overall what was going to be happening, including details about the BSDCan widow/widower/orphan tour, and more importantly, the 621 rule, which we talked about. The following morning, we were presented with tea and coffee and muffins and other goodies to help prepare us for the day ahead. The opening keynote was The Tragedy of Systemd, covered what Systemd did wrong and how the BSD community could improve on those ideas to get the advantages without the disadvantages of Systemd. And then he goes on, with the exception of Michael W. Lucas's SSH key management talk and Kirk McCusick's The Evolution of FreeBSD Governance, I pretty much attended all of the ZFS talks, including a lunchtime BOF hosted by Alan and Matt Ahrens. Coming from the FreeNAS community and being involved in the community, this is where my main interest and motivation lies. Since then, I've been able to share some of that information with the FreeNAS community on the forums and in the chat room.
Ah, excellent.
Yeah, that's 1, 2, 3. We had like 6 or more ZFS talks. It was quite a bit going on there.
But yeah, see, this is the why we urge people to go to these conferences, because then they can share what they learned there in their communities, be it FreeNAS or wherever that might be. And this is fresh knowledge you just got.
Yes, but also it gave Dave, which he didn't mention, the chance to actually proxy the most common questions from the FreeNAS forums back to us as the developers, where, you know, what features they want and what questions they have and what problems they have are not something we automatically know. Actually having just a couple representatives from that community come to the conference and actually talk to the developers about where the weak points are and where the confusion is can make a huge difference in steering what gets done next.
Yeah, so great.
Dave goes on. He also attended the Speculating About Intel Lunchtime BOF hosted by Theodor Rath, which proved to be interesting. And then he says, the talks ended with a wrap-up session with a few words from Dan covering the record attendance and made very clear that there was no BSD cabal, followed by the handing over of Groff, the BSD goat, to his new owner, and thanks from the FreeBSD Foundation to various community committers and maintainers, and finally ended with the charity auction, where things like a Canadian $20 bill were sold for $40, a signed FreeBSD Foundation shirt originally worn by George Neville Neal, and a lost laptop charger, Michael's used gelato spoon, a bunch of books, and the last, and more importantly, the second to last cookies of the conference were auctioned off. After the auction, we all headed to the Red Lion for food and drinks, sponsored by IX Systems. And he just says, I would like to thank the BSDCan organizers, speakers, sponsors, and everyone who attended for a great conference, and I certainly hope to attend next year.
Yeah, so next year we should get him to the, not just the conference, but also the Dev Summit.
I tried that already, but he didn't want to take that many days off work.
Oh,
he
right.
managed to sneak out of work on Thursday and just do the conference on Friday and Saturday.
I see. Okay. Well, yeah, maybe there's a change in the future, so that's certainly open for you to attend. Yep. All right. Yeah, thanks for that great report. And again, if you've been to BSDCan for the first time, or as a,
for the nth time.
Yep. Pretty much the same for us. Send us a trip report, how you like the conference, what sessions did you go to, what people did you talk to. This is what people want to know.
What did you get out of the conference that was useful? What were you hoping to get that you didn't get? And what can we do better next year?
Yeah, and especially from newcomers like this one, how did you find the place? For us, it's like, same building like last year and the year before. But if you're newer to the place, it's, not that easy to find.
I remember a couple of years where it's been in different places.
Yeah, it moved around sometimes when the university already allotted the rooms to other talks and lectures. But yeah, mostly it's been in the Demaray building, at least the times I attended.
Anyway, email your trip reports, feedback@bsdnow.tv.
BSD Bits for this week start off with Robert Watson. It's a post from 2008, almost 10 years ago, but still important, on how much FreeBSD is in macOS 10.
Yeah, so this is a response on the FreeBSD advocacy list to someone saying, it is just too frequent that I hear statements that essentially say, macOS 10 is just FreeBSD with an Apple GUI on it, and that's not true. And goes on to talk a bit about that. And Robert Watson, who would know, because he was involved in some of it, says, I'd like to be a bit cautious about saying that XNU is a mock kernel. XNU is not a microkernel, but it contains a lot more mock code than FreeBSD does. However, XNU contains massive amounts of FreeBSD code, including countless IPC models, security parts, VFS, network stack, distributed file systems, etc. Saying that macOS 10 is just FreeBSD with an Apple GUI is certainly false on face value, but it's not correct to say that the kernel isn't in significant parts FreeBSD derived. Here's what I found in my most recent XNU kernel source drop from Apple. 21 million lines of code labeled explicitly as BSD, largely from FreeBSD, but heavily modified. 16 million lines of code labeled explicitly as mock, largely from the OSF mock project, but heavily modified. And then only 676,000 lines of code labeled explicitly as security, usually actually the Trusted BSD Mac framework, which is from FreeBSD, but with modifications, leaving 2.7 million lines of device driver code in the IOKit tree, which is mostly from Apple, and 2 million lines of code in libkern, which is mostly Apple code, including C++ parts from IOKit and some zlib and so on. And then some loose ends such as libsyscall, which is really user space code, but is stored in the kernel source tree, configuration files, GDB macros, etc. The above is just the XNU drop, so excludes a large number of additional loadable kernel extensions, or KEXs, which include a lot of device drivers, largely Apple and vendor code, but also things like SMBFS, which is pretty much verbatim FreeBSD code, and so on. So at least back then, the amount of code that was actually unique from Apple was a lot less than the amount of code that was from FreeBSD. It'd be interesting for someone to run those numbers again now and see, in a modern version of OS X, what percent of the code is from FreeBSD, from other open source projects, and how much is actually unique to Apple.
Yeah, 10 years later, there's certainly a number of code changes, either more or less. It undergone quite a bit of changes, so that's certainly good to reevaluate. Okay, another piece we found is why Intel Skylake CPUs are sometimes 50% slower than older CPUs. That's a bit longer article, but we'll briefly go over it. Oh, it's the comment section that makes it long, so that's why. But there are a couple of pictures that analyze how these CPUs, especially since you are running the same operating system on the same hardware, you just exchange the CPUs, why they make things differently, up to 50% slower.
So it's specifically the pause instruction. So this is documented in Intel's architecture manual. And they specifically say that on, for example, a Xeon E5 1620v3, which is, I think, Haswell, a pause instruction will last about 4 nanoseconds. But on a Xeon Gold 6126, which is Skylake, a pause instruction will take 43 nanoseconds, or actually 10 times longer. And so if your application is running pause in a tight loop waiting for a lock to free up or something, it can end up waiting longer than you expected. So the excerpt from the architecture manual here says, the pause instruction is typically used with software threads executed on 2 logical processors located in the same processor core, waiting for a lock to be released. Such short wait loops tend to last between 10 and a few hundred cycles. So performance-wise, it is more beneficial to wait while occupying the CPU than yielding to the OS. When the wait loop is expected to last for thousands of cycles or more, it is preferable to yield to the operating system by calling one of the OS synchronization API functions, such as wait for single object in Windows. The pause instruction is intended to temporarily provide the sibling logical processor, so that's the other thread running on the same physical core, which is ready to make forward progress, exiting the spin loop with competitively shared hardware resources. The competitively shared microarchitecture resources that the sibling processor or logical processor can utilize in this Skylake microarchitecture are more front-end slots to decode the iCache, LSD, or IDQ, more execution slots, and a bunch of other bits. And then the highlighted section says, the latency of pause instructions in prior generation microarchitectures is about 10 cycles, whereas in the Skylake microarchitecture, it's been extended to as many as 140 cycles. As the pause latency has been increased significantly, workloads that are sensitive to pause latency will suffer some performance loss. The increased latency, allowing more effective utilization of competitively shared microarchitectural resources to the logical processor ready to make forward progress, has a small positive performance impact of 1 to 2% on highly threaded applications. It is expected to have negligible impact on less threaded applications if forward progress is not blocked on executing a fixed number of looped pause instructions. This will cause a small power benefit on 2 and 4 core systems. So depending on how the software is written, it probably won't make a difference. But if your software happens to be written in one specific way, this 1 or 2% gain could end up costing you a lot of performance.
Yeah, that's unfortunate, but that's the reason why.
Yeah. So looking at the latency or number of CPU instructions that it takes, on Sandy Bridge, pause took 11. On Ivory Bridge, 10, on Haswell and Broadwell, 9, and on Skylake 141.
Well, what I like is that we now have the tools to measure that. Earlier, like in the 90s, we were like, the CPU is slow. I want to return this. And now we have like tools like dtrace and all these shiny other tools that make us dive deep into the CPU instructions to figure out why is this so slow.
Mm-hmm. So it turns out if you run a heavily multi-threaded application on Microsoft.NET on the latest hardware, things can become much slower. Someone's already noticed this back in August of 2017 and made changes to the .NETwork framework for version 4.8, but that version's still a year away from release. And so some applications might still be affected. And it'd be interesting to see how much of this might be going on in operating system code as well, not just .NET code.
Yeah. Okay.
And you can also see how it scales across the number of CPUs from the nice graph they put up here.
Yep, it's nicely illustrated to see how big the differences are, or how they came up with the numbers. Okay, next item is that Chris Stubbs is looking for somebody to maintain the manpages.bsd.lv, especially the Unix man page, which cover a lot of history of Unix, and apparently he doesn't have time for it anymore, but wants to have someone to maintain those and give it a little bit of love because some of the links seems to be broken, and someone should be taking over that ideally. So if you want to do that, then you can reach out to Chris Stubbs, or if you don't know his email address, but I think it's linked on manpages.bsd.lv, then you can reach out to us and we'll connect the two. And I think it's important to have these historical man pages still available, because there may be a day where we need to go back and see why it was the way it was way back when, and having those around is good to look certain things up again. Oh, next up is also a nice thing that we called Cam Control saves the day again. Formatting floppy drives is a USB in a USB floppy disk drive. Remember floppies?
Yeah. So this is on Reddit, and it says, I recently bought a USB floppy disk drive for my FreeBSD machine and tried to format some floppy disks. Turns out there is no tool for this purpose. FD format doesn't work, as it's designed to work on the FDC device, not the USB version, which are actually SCSI floppy drives. The cam control format doesn't work correctly either. It just formats the first track of the disk. The Linux utility UEFI format doesn't run on FreeBSD, obviously. So after reading the specification, I decided to write my own tool, basically a shell script that runs a couple of cam control raw commands and feeds the required track numbers into and manually tells the drive to format the disk.
Hey, nice. That's how it's working. That's how it's doing the formatting. If you ever wondered, oh, I need to format a couple of floppies, what's it's doing? It's making sounds, but this is what the actual software is doing.
So later in the comments, the poster says, I have a retro project running which requires me to transfer data to a 8286 computer running MS-DOS using the floppy disks, and that's why I was getting the floppy disks to work.
Yeah, okay. So, okay. Well, see, it's still useful. The first thing I always do when I start a new VirtualBox is disable the floppy drive because they add it all the time for a new virtual machine. It's like, why? I don't even have a floppy to put into my USB or into my virtual floppy drive. So, yeah. Okay, but that's a different story. The next one is we have a 32 and plus great indie games now playable on OpenBSD current and 7 currently on sale. Excellent. If you're a gamer out there and don't want to switch to a different operating system, then you can now do this on OpenBSD as well. And some of these are pretty good titles. So they list the ones that are on sale. Rogue Legacy, Super Rad Ray Gun. Sorry, shortly after I posted this, the sale ended. Okay, too bad. Cryptarch, Escapegoat, and Escapegoat 2. Is that Scapegoat, probably? Yeah. Apotheon and Capsized. Okay, so if you are into gaming on OpenBSD, then you can now do this. Plus the other 32 that are not on sale currently, but still work the same as the other ones. Very cool. That's a weekend of gaming.
Yeah. And this news is probably too late for most people because I think the meeting is already half over at this point. But the Warsaw BSD user group, bsd-pl.org, is meeting today at, I think the meeting started 2 hours ago, maybe 3 hours ago.
Yeah, so it's
wrapping up about now,
9:30.
or it's actually over already.
Too bad.
But now that you know about it, you can make sure to go next month.
Yeah, it's a recurring thing.
Yes, the meeting was hosted at the Wheel Systems office in Warsaw and featured 4 15-minute talks and then group discussions. The first one was using a YubiKey for FreeBSD users. So, that one might have been useful to you, Benedict.
Yep, but it's now in the, there's an article in the current FreeBSD journal. And cool. I still have mine. I've used the other one. I used the smaller one, and now I'm also switching to the other one. So with that tutorial, that's super helpful.
Yeah, and then there was Andrzej was speaking, and then Pavel Doedek was speaking about his Zero Trust initiative, which is basically even for commercial security appliances, providing the source code under a license that says you can inspect the code, but not make your own product out of it, so that we can get to the point where if you really want to trust this commercial appliance, you want to be able to inspect the source code for it, and how that works. And then Kamil Zerkidia was talking about monitoring and what's in your administrator's tool belt for that. But they have a link to register, and you should check it out and attend next month if you happen to be in the Warsaw area.
Yep, it seems like it's becoming a regular thing, which is good. More BSD user groups and knowledge sharing this way. And yeah, who knows? Maybe there's a future BSD committer in that.
Yep. Last month's talks included introduction to the FreeBSD project, checkpoints in ZFS, and CubesOS.
Oh, wow. I would have liked to watch those. Are they in English or in Polish?
I imagine in Polish.
Oh, okay. Well, maybe there's translations. We'll see.
Speaking of inspecting the source code before you trust something, Tarsnap, Online Backups for the Truly Paranoid, is the only online backup service that has crypto you can trust because you get the source code for the client so that you can inspect it yourself.
Yep, have a look at it.
Have someone you trust inspect it if you aren't going to be able to understand it yourself.
Yeah, if you're not that deep into crypto, but you can find that this is pretty much trustworthy to use, and people have used that to build all sorts of things like extra clients for that. Of course, this is not officially supported by Tarsnap, but you can just use the source code, compile it on your local machine, and this way you get your own version of Tarsnap for your systems to use and back up into the cloud. And it's super easy. There's a getting started guide and documentation section to make certain preparations, like generate the key, which you should always keep and never give out. And with that, it's super simple. It's basically like using tar, the the command for putting files together in an extracted archive or an extractable archive, and that is being deduplicated and then sent off into the cloud where it's being stored for you to retrieve it one day in case you need it.
Yeah, that's pretty much all there is to it.
Yeah, again, it's encrypted. No one can read it except you holding the key. And if you don't lose the key, a big part of that documentation mentioned that you should back up that key in certain ways. And if you have that, then you're pretty much set of getting your files back that you hopefully regularly via cron job back up with tarsnap. The pricing is very competitive because it's just 25 cents per gigabyte, and you can make there's an FAQ entry that shows you how you can pre-estimate how much it would cost you in like the actual cost for doing the regular backups. And for a couple of gigabytes, you will see this is basically a couple of cents. So this is exactly a reason why you should get started right away doing those backups, and then rest assured that these will be backed up in a secure way and you can get them back as long as you have the key. All right,
yeah,
that was our
don't
sponsor.
Lose the key and it'll be fine. It only takes $5 to get started. Why aren't you doing backups already?
It's that simple. So that's our sponsor for the feedback and questions section. That one goes off with a question about adding a disk to ZFS by Ron, which goes like this. BSD Gurus. Oh, wow. That's already an opening. I have listened to BSD Now since the very first episode. Oh, yeah. Right. That was way before my time.
5 years now. I can't believe that.
There's a lot of episodes, yeah. Okay. I enjoy all the BSDs. Vacillating between all of them for one reason or another. I tended to stay away from FreeBSD because it was so popular. I hear Alan saying, that's weird. Come on, say it.
That's weird.
Yeah. Okay. However, that all came to an end with installation of GhostBSD. Now my development workstation is FreeBSD, and all my servers are FreeBSD, FreeNAS included, and pfSense as well. Shameful disclosure. Because I was not using FreeBSD at the time, whenever something about ZFS came up, I would only half listen. What is this? ZFS now? Well, I've tested the ZFS waters and I'm hooked. Now I have a ZFS question. Okay, here it goes. Background. I have a FreeBSD file server that I need to turn to a new desktop since my other workstation crashed and burned. I wanted to save the data on the disk used by the file server, which is a 1 terabyte disk. Added a 3 terabyte disk as my primary disk and installed GhostBSD to that drive. Now I want to be able to mount the old drive, formatted with ZFS, of course, in order to access the files. So how do I do that? I created a new pool called Swimming. Oh, I see where this is going. But I'm not sure how to mount the partitions of the old drive. Help me, Alan One. You're my only hope.
Right. So what you want to do is run zpool import, and it'll give you a list of all the pools on the system that are not yet imported. And you should see your old pool. So then just zpool import whatever the name of that pool is that's on that 1 terabyte disk, and it will show up mounted under its name. And then you can do something like ZFS snapshot it, and then ZFS send that data pipe into ZFS receive onto the new pool, and then copy all that data onto your new 3 terabyte disk.
Yeah, the notion of partitions that you mount singularly to a different operating system is not a thing that is typically done in ZFS. It can be done, but
since ZFS is almost always multiple disks, it has this concept of import where it finds that partition on all of the different disks. In your case, because it's 1-to-1, it seems like it would make sense to talk about it the old-fashioned way, but it's not. So mostly you just need to run zpool import and then the name of your pool. And if you just run zpool import by itself, it will give you a list of the pools that are around.
Yep. And it closes with, now that I'm a FreeBSD Padawan, I'll be asking you guys all the questions everyone else is afraid to ask. Yes, Jude Vader, I have succumbed to the dark side. Excellent. Yeah, send us all the questions that you have with that kind of attitude. Even though you've been starting out with the BSD Now podcast from the very first time, it's not a shame to ask these questions again if you've only been half listening. So, all right. On to the next one. It's Marshall with another ZFS question. Oh, here we go. Thank you so much for the ZFS talk. 4 years, 3 dead disks, 3 different operating systems, same pool, 0 data loss. Oh, cool. I finally created a new pool and would like to have a confirmation or explanation on the way the output appears. So the original is 2 times 1 terabyte mirrors VDEF, total 1 gigabyte. The goal is a 2 times 1 terabyte stripe mirrored to 2 terabyte single disk with a total of 2 terabytes. There's Kubuntu in use and 2 terabyte Toshiba hardware, 1 terabyte Western Digital, and 1 terabyte Seagate. Auto expand is turned on apparently. Started with the 2 1 terabyte disks in a mirrored VDEF, attached the 2 terabyte as a third mirror, allowed it to finish resilvering. Then detached both 1 terabyte disks, leaving a single disk. No redundancy made me nervous, but it gets worse. I then created a new stripe pool with the 2 1 terabyte disks, created snapshots on each dataset on 2 terabyte disks, and used ZFS send pipe to ZFS receive to copy datasets from the 2 terabyte to the 2.1 2 times 1 terabyte pool. So far, so good. I then destroyed the 2 terabyte pool and attached the 2 terabyte disk as a mirror to the 2 times 1 terabyte pool. The output of ZFS.
How did you do that? If the 2 1 terabyte disks were striped, you could only attach to one of them, not both.
Yeah. Is it described the wrong way, or is it really happening?
I'm not sure. We'll get to that, I guess. So go ahead.
Okay.
Reading.
Yeah. The output of the ZFS status looks odd to me now. The data and file system sizes look fine, so I think I did everything correctly. I tried adding the 2 1 terabyte disks as a striped VDEF to the single 2 terabyte disk, but could not find a way to do so. Here we go. Hence the copying. Is that possible? That would have saved some time.
Okay, so looking at the zpool status output further down in the email, you've attached the 2 terabyte Toshiba as a mirror to the 1 terabyte Seagate, and then you have your 1 terabyte Western Digital unmirrored.
Okay, so he's lost a bit of space there.
Yeah, so basically you have a mirror of a 1 terabyte and a 2 terabyte disk, giving you 1 terabyte usable, and then a stripe of a 1 terabyte disk, getting you a second 1 terabyte usable. So that's not what you want. So you'll probably want to do zpool detach from storage the Toshiba disk, then partition that disk into 2 1 terabyte chunks and attach 1 terabyte chunk to the Seagate and 1 to the Western Digital. But in general, I don't recommend these types of setups. They're very, very ugly.
Yeah, with mixed sizes and, well.
Yeah. This is slightly better than trying to do something like creating a mirror of the 2 terabyte disk and then the 2 separate disks concatenated. But yeah, this is
this is
pretty bad. You should.
So how does he get out of
buy a second 2 terabyte disk and create one mirror of the 1 terabytes and a second mirror of the 2 terabytes and have 3 terabytes usable?
Yeah. Basically start a new pool and then move gently the data over.
He can unwind what he's done here because you can always detach from a mirror. So zpool detach storage the Toshiba, then partition the Toshiba, zpool attach storage Seagate half Toshiba, and then zpool attach storage Western Digital other half of Toshiba, and you'll end up with what you intended to do. Although I would say that's still not a very good idea. To better understand the output and why it's not what you expect, if you do zpool list -v, it will actually show the available space from each drive, and you'll see that only half of the Toshiba is in use and the other half is waiting for the Seagate to get bigger, which is never going to happen.
Yep. Yeah, it's not a total failure, but it's just a different, unusual way I set it up.
Isn't going to deal with splitting the 2 terabyte drive for you. You're going to have to do that yourself.
Okay, that hopefully gave you a couple of points to get out of that pool mess, to swim properly. Okay, next up is Thomas. Calling Alan directly the myth perpetrator. So that one goes, hey guys, I'm sure I have heard Alan say that work in a ZFS pool is disturbing according to which VDEV
Distributed.
distributed, of course, sorry. Distributed according to which VDEV can take the work and is done the fastest. It seems this article and blog that we have a link here is in disagreement with that. Could you possibly shed some extra light on this issue?
Right. So they provide a link to some random blog and for some reason have more confidence in that blog than in me. But a couple of things. A, that blog is using an old version of ZFS on Linux. And so I don't know when Linux is or will get that feature. And the other thing is, it's not that simple. And so the old way ZFS did it was aiming for all the disks to get full at the same time. So if one VDEV was more empty, it would get more of the writes. The new way is based on performance, but performance isn't static. It doesn't give more data to that disk because that disk happens to be, a higher RPM or something. It's based on a bunch of factors, including the fragmentation. So in ZFS, by its nature, as a disk gets more fragmented, or as it gets more full, it gets more fragmented, and as it's more fragmented, it's slower. So in the modern version of ZFS, with the new write allocation feature, it still happens that the emptier disk usually gets more of the work because the emptier disk is faster. Faster in ZFS terms, not necessarily faster in raw terms. As a disk is more fragmented, it takes longer for ZFS to find a chunk of free space and go use it. Plus, on hard drives, the space nearer the front of the drive is faster than the space near the end of the drive. So, if you have a modern enough version of ZFS, and I don't know if the version of Linux that the jrs-s.net guy is using is that new or not. I don't really follow the Linux version. But if you have a very new version of ZFS that has this feature, it will give every VDEV some work. And then whichever VDEV comes back first saying, I've finished my work, will get the next work. That's not just based on the speed of the drive. It can also be how full it is, how fragmented it is, how much other stuff is going on, lots of other factors. But in general, the disk that's more empty will get the work done faster because it'll be less fragmented. So it's not uncommon to see the more empty disk look like it's getting more work. You can tell how full each of your different VDEVs is relative to each other by doing zpool list-v.
Yeah, that's your pool version. Yep.
So if you do zpool list-v and you look, and I see that my RAID Z2 of 5 terabyte drives has 8 terabytes of free space, and my RAID Z2 of 8 terabyte drives has 18 terabytes of free space. And it turns out that the bigger drives are actually faster as well, but only marginally. So when writing, I will see probably about equal amount of writes going to each of those drives. But as those older drives get fuller, they're only 48% full right now, and 8% fragmented, so that's not very much. But as they get closer and closer to full, the fragmentation level will go up and the speed will go down, and that will cause them to start get less and less writes. There are also some sysctls that control, don't allocate to a device if it's more than 90% full unless every device is more than 90% full, which you can use to try to purposely wiggle the load about and so on.
Okay.
So no, it is not a myth. It's just a newer feature that may not be in every version of ZFS yet. If you want more detail about how it actually works, the talks are from, I think, BSDCan 2016 and 2017. Those seem like a while ago, but that was while it was still in development before it was actually finished and committed. And so it just takes a while for that feature to percolate everywhere.
Yeah. I saw this at my ZFS tutorial where we had a couple of Linux folks try out ZFS on their favorite operating system kernel, and it was like 3 different versions already, and they had the comparison of FreeBSD, which I used as a reference.
The version that is included in Ubuntu by default was quite old. It was like 0.6 point something.
Well, they even had Debian there, so this was
yeah,
a much older
depending on
version.
a bunch of different things, you can get vastly different versions of ZFS. Just like you can across versions of FreeBSD, right? If you're running FreeBSD 10.4, it's not the same as the ZFS you get in FreeBSD 11.2 that came out today.
Yeah. Yeah. So, and there are, of course, ways to upgrade to the latest version. And that would hopefully give you a bit more.
Anyway, so it's not just based on, which disk has the most RPMs or most cache or anything like that. So it's not as simple as the fastest disk always gets more work. It's just the disk that finishes its work gets the next bit of work. But again, it's also not disk, it's VDEV. And so, when you have whole RAID Z groups, the whole RAID Z group is waiting on the slowest disk in the group. So even if, 5 out of the 6 disks are done the work, if the sixth disk is not finished its work yet, then that VDEV doesn't get any more work. And it goes on from there. And then you can also end up with QDEVs where you've actually make sure that each VDEV has 3 units of work waiting for it and so on. So it's not that simplistic. So how you measure it can make it look like things aren't happening the way you might expect.
Yeah. So Alan's not perpetrating any myths here. It's just a different ZFS version they were looking at.
Yeah. Well, or just the way they were measuring it as well.
Okay, that's been cleared up. And last in our feedback section is another ZFS question. So all 4 of those are ZFS questions of a certain kind with a ZFS IO stats per dataset question. So this goes. You asked for questions for the pre-recorded episodes coming up. So here you go. Excellent. Someone listened to us. I'm trying to optimize performance for MariaDB, MongoDB, and Tomcat app, mainly writing to a single pool. I have read all the articles about getting the right data, record size, etc., but after a previous round of tuning, I actually think performance may have gone slightly down. The switch has come from 8K to 16K blocks on the InnoDB dataset and creating a new dataset for the InnoDB logs with 128K. Both datasets are LZ4 compressed. Now it's possible that the DB load increases slightly since the change, but my 24-hour average system-wide I/O weight CPU percentage went from 2.2 to 3% to 3.5%, so nearly double. But this is still so low. Okay.
Yeah.
Yes. This is
so I/O weight is kind of a weird stat, and it depends on a bunch of things. Also. Yes, setting your InnoDB to 16K is normally the right one, but with LZ4 compression, you end up having block sizes that aren't necessarily that big, right? You have 16K, but you end up compressing it down to 4K and so on. It also matters what your underlying disk sizes are, what you've set some of the other options to. In particular, for InnoDB, or any database really, where you want to look at is the redundant metadata setting, and switching that from all to most, because the problem is you write your 8 or 16K of data from your database, and then you also write, say, 3 sectors of metadata, or multiple copies of metadata, or multiple sectors of metadata, and multiple copies of each of those sectors, and you end up writing more metadata than you did actual data.
Yeah, for the database and for ZFS.
Yeah, by switching the redundant metadata property to most instead of all, you will ratchet down the amount of metadata you're writing, and it could make a big difference there. You also probably want to measure things other than just system-wide I/O weight, because other load could impact things on that and many other things. Which I guess mostly leads into his actual question here.
Yeah. Is there any way using the ZFS tools to monitor either IOPS per database, per data set, like zpool stat? What is zpool IOStat? Isn't it?
No, but zpool IOStat -v will give you per disk, but there's not currently a way to do it per dataset.
Yeah, true. Yeah. But this is more, or the most detailed one from the ZFS tools that are provided with ZFS. Is there a ZFS way to see application write request buffer sizes? No, because ZFS doesn't care about the actual applications running on it.
dtrace can do this. So in the advanced ZFS book, we have dtrace scripts for looking at the average sizes of the writes, the average latency for writes, the average latency of flushing a transaction group in ZFS, etc. And yes, those are all mostly OS dependent.
Yeah, they're easily adaptable to a certain application.
But yes, so the compression might be throwing things off a little bit. Although in general, it'll be saving you work and so is helpful in that way. But
there's no ZFS native
what
way.
The data in your database is like and how compressible it is, where actually a larger record size, say 32K, might work better because you'll get all 32K and you'll be able to compress it down into 4K sector, whereas with 16K, you're managing only to compress the same amount and not necessarily gaining the advantages of it. It also depends on your database, whether you modify old data a lot or if it's kind of append only. If it's append only, then even larger record size can be better because you get more compression and more savings out of it. But the point of setting the record size to 16K for InnoDB is avoiding the read, modify, write cycle, right? The default 128K block is going to have a bunch of those 16K blocks in it. And if you modify one of them, you read the whole 128K, modify the middle of it, and then have to write the whole 128K. So you have this write amplification effect where you're actually writing 128K every time you want to change 16K of data, which means you're giving your disk more work that it doesn't need to do if you use a smaller record size.
Yep.
So yes, there's a lot to the tuning. And I don't think the 24-hour average of your system-wide I/O weight CPU percentage is necessarily the right way to measure it. Partly because there's not even such a thing on BSD. In general, the CPU time isn't actually spent if you're just waiting for I/O. It's seeded to let other applications use the CPU. So,
yeah, I would recommend doing long-term measurements, not just. I mean, you did a 24-hour average.
But I/O weight isn't necessarily the right thing to measure. You might actually want to look at some kind of actual SQL benchmark and see what you're measuring there. Other things to look at is also making sure that your MariaDB InnoDB buffer and your arc are not fighting each other. You didn't mention what size you've set your arc to and what size you set your MariaDB InnoDB buffer to. Because you can end up caching everything twice. And so you either decide to not cache the database files, the actual database information in ZFS and let the InnoDB cache do it. But because of the compressed arc feature, if you're using a new enough version of ZFS on Linux to have compressed arc, it might actually be better to have a much smaller InnoDB buffer and let the ZFS arc do the caching because it's going to cache the compressed version. And if you're compressing your database 3-to-1 or 4-to-1, all of a sudden, you need 4 times less RAM to cache that data.
Yep. Another thing that I just found rereading that, you say you're using MongoDB on that single pool. MongoDB recommends in its documents to use XFS. So did you use that on a volume and formatted that to XFS?
I wouldn't do that. They just say XFS because they mean not ext4.
Yeah, true. But this could also be something that MongoDB...
I've definitely done MongoDB on ZFS before. I don't know what the right record size is for MongoDB off the top of my head.
Yeah, it's interesting to have this mixture of databases or a Tomcat even.
I think because MongoDB does mmap, there might be really interesting performance pathologies in ZFS with MongoDB just because of the heavy reliance on mmap.
Yeah, but I guess that's a couple of pointers for you to figure out where the performance went. Still, this is not an increase from 2% to like 80% or something. This is still well within limits. But yeah, it's good to see where the performance goes. All right, that pretty much covers our feedback and questions section, which also closes our episode for this week. Again, if you have any questions, feedback for us, or something that you found that we should cover in a future episode, send this to feedback@bsdnow.tv, and that's a good chance that we'll cover it in a future episode. Thanks for watching and see you next week.
See you next week.